Welcome to video number 4 in our limit series of our maths module. So for this video we're going to be looking at some quite complicated polynomials divided by other quite complicated polynomials, and we're going to be taking the limits to 0 and infinity. If we were taking these limits to any sort of other numerical values, just substitute in the values, see what you get, and that's going to be your limit. For these, we're going to treat these in a bit of a different way. So we're going to start with a, and this is a limit to 0. So what we've got here is we've got a polynomial with the highest magnitude there being x to the 3 on the top, and the bottom is also x to the 3 there. So what we're going to do is now we're going to look for a point where we can have just some values not dependent on x. So we're going to divide everything on the top and everything on the bottom by x. So this is how we treat these first. For 0, anything to the limit of 0, we try and get values which are not being multiplied by x. So for top, everything divided by x, we have 11x squared plus 33x plus 35. And on the bottom, we have x plus 3 plus 2x squared. Now remember this, as I said with most of my videos, I won't write out the limit every time because it's just wasting time. But now looking at this is the limit to 0, we can substitute the 0 value in to everything we have, and this term then can be 0, this term can be 0, this term 0, and this term is 0. So what we now get left with is 35 over 3. And that's our limit for that one. We've got two very similar limits, but slightly different, and we'll show you how we treat those. So for b and c, they're the same limit, just with the fraction flipped over. So for the first one, b, if you notice, we have a lower magnitude on the top. So we have x to the 3 is the highest on the top, and on the bottom is x to the 4. So again, we're going to try and get some terms which don't depend on x in there. So we have an x squared there, that's our lowest, so we divide everything down by x squared. So for the top then, we now have 11x plus 33, and this is all over 40x squared plus 5x. So now at the top we have 11x, and that's being added to something, so we'll get rid of that. But on the bottom, since there's no other terms on the bottom, they all still depend on x. The bottom part is becoming 0. So what we will now have is 33 over 0. And from our other videos, we'll know that anything divided by something almost reaching 0, we now have something which is going to infinity. What we now also have to consider is, looking at this, does the direction at which we approach infinity matter? So the part here, that at the top does not really matter. We can ignore this part. If we look at the bottom parts there, if we approach it from the positive side, we have something on the positive side of 0, squared still on the positive side of 0 plus something, positive on the positive side of 0, so on the positive side we're fine. But now if we look at it from a negative side, we need to consider that the x squared is exponentially smaller than the x. Now this is a squared, so when this is approaching 0 from a negative side, this actually is positive. But because it's exponentially smaller than the x on the negative side, the sum of these two will be negative. So it will be getting divided by something slightly smaller than 0, which is from the negative side. So as x goes to 0 from the positive side, our function of x goes to infinity, and as x approaches 0 strictly from the negative side, our function of x goes to negative infinity. Okay, and now we'll continue on to C. Now C is just b flipped over. So what we're going to do now is we're going to take exactly what we've done to it there. We've divided everything down, and we've been given this result here, 11x plus 33 over 40x squared plus 5x, but it's the other way around. So we'll just flip that over first. So we're left with 40x squared plus 5x all over 11x plus 33. And now for this one, we're going to look at this and say, right, well, this is 0, doesn't matter, 0 and 0. So we're left with 0 divided by 33. So the limit of this, as x goes to 0, f of x goes to 0. Now, does the direction in which we approach 0 matter? No, because we're converging to a value. This is diverging away, but this is converging to a value of 0. So it's always going to be coming towards 0, so no, the direction doesn't actually matter. And finally, we're going to be looking at D. Now, D is a bit different. D, we are looking at a limit to infinity. So for D, what we want to do is, we are going to divide up, when we're going from 0, we're looking at our lowest term here. So we're looking at our singular x, we're looking at our x squared. This time, we're ignoring the x to the 0, we're ignoring the x to the 1, the x squared, we're looking at our x to the 3. And this is important because at the moment we've got infinity plus infinity plus infinity plus 35, infinity plus infinity plus... You know, it's hard to understand what to do. So what we're now going to do here is we're going to get rid of these higher terms, and along with them all of the other terms. So we're going to divide everything in this by x cubed. So we're left with the limit of x going to infinity for 2 plus 11 over x plus 33 over, sorry, that's, well, yeah, we can put in infinity, actually. I was meant to put x there, but it doesn't really matter. Infinity squared, because we'll get rid of the limit here. That's a mistake, but it doesn't really matter too much. Plus 35 over infinity cubed, and this is over 1 plus 1 over infinity plus 1 over infinity squared plus 2 over infinity cubed. Now all of the powers on infinity at this point don't really matter, because what we're going to look at now is we're going to say, well, anything over infinity is effectively 0. So we're going to say to ourselves now, this term is 0, 0, 0, 0, 0, 0. We have 2 plus 0 plus 0 plus 0 and 1 plus 0 plus 0 plus 0. So we're left with 2 over 1, which is 2. So as x goes to infinity, a function of x goes to 2. And that's how we deal with that. So once again, I'll quickly just go over this. If we're looking at something for 0, we're looking at our lowest, and if we're looking at something for infinity, we're looking at our highest. And we can work our ways down to simplify what we have, and we can calculate our limits from that.